Hello everyone, I hope you all are doing well. My name is Andres Gonzalez and my topic for the presentation today is fueling and storage of LNG in trucks. So LNG fueling stations, they are structurally similar to gasoline and diesel stations since they both deliver liquid fuel. However, the difference is that an LNG fueling station, which stores and dispenses LNG as supercooled liquid, requires cryogenic equipment, technology, and expertise. The three options for LNG fueling are mobile fueling, containerized fueling, and permanent large fueling stations. Each of these options will be covered in the following slides. And in 2019, there were approximately 75 LNG fueling stations available across the United States. These stations are usually positioned in areas that service the long-haul trucking industry. So our first fueling option is a mobile fueling. The mobile fueling is the most adaptable option for an LNG fueling station. A mobile LNG fueling station is similar in appearance to a tanker, like the one in the picture. However, this one has a fueling dispenser attached directly onto it. This method of fueling is ideal for refueling fleets on a work site, mining site, etc., and can be placed wherever is more convenient. The tanks for a mobile fueling can carry up to 16,000 gallons of LNG and are capable of fueling up to 15 vehicles per day. It is easy to take away from the work site once the tank is empty, and this type of fueling station is also ideal as an entry-level solution for startup and test projects. This is perfect for temporary fuel solutions. Okay, so next is a containerized LNG fueling. The containerized LNG fueling method can be considered a hybrid between a mobile fueling station and a permanent fueling station. This method is ideal for temporary workstations. It is also ideal for vehicle fleet bases or remote locations. It provides a semi-permanent fueling station, and it's considered like a Lego block where it is locked in its place inside of the work location. And all the station components are mounted on twin skids to facilitate the transportation inside of the site. The third and last type is the permanent large fueling station. This permanent fueling station is the one that most looks like a normal gasoline and diesel fueling station that we're all used to. This fueling station is equipped with a large storage tank where the LNG is stored at negative 162 degrees Celsius and a pressure of approximately 3 bar. It requires an air vaporizer system to heat the LNG and increase the pressure for fueling into a vehicle, which I will cover more about this in the next slide. LNG circulates through the air vaporizer system to cool the system before the fueling can begin. This leads to partial evaporation of LNG called boil-off gas, or BOG. After this, the LNG returns to the storage tank in its gaseous state and it increases the pressure. This can cause an environmental and safety hazard and a financial loss. All this can be avoided by increasing the amount of fueling per day. But if you can't increase the amount of fueling per day, a company called Cryostar came up with a solution to avoid the boil-off gas, even without increasing the number of vehicles fueling per day. It uses a system to convert cold LNG into saturated LNG on demand outside of the storage tank. This makes it faster and more efficient than using the air vaporizer system, and it protects against the boil-off gas hazards. Fueling an LNG truck is similar to fueling a diesel truck, but not quite the same. First, the LNG must be saturated, meaning it can't be dispensed into the truck's fuel tank at the same temperature and pressure as it is in the LNG storage tank. The LNG is heated from minus 162 degrees Celsius to minus 130 degrees Celsius, and the pressure is increased from 3 bar to 8 bar. This is due because the LNG is stored in the truck's fuel tank as liquid, but it is injected into the engine in a gaseous state. What does this mean? Why can't the LNG be dispensed at the same temperature and pressure that is stored in the storage tank? If the LNG was dispensed at the same temperature and pressure, the pressure would then become too low to supply the engine. Saturated LNG makes it possible to ensure a constant supply to the engine even when the vehicle is moving. Although it may look like a regular gasoline or diesel station, the LNG must be treated much more carefully and professionally. The LNG is extremely cold and could cause severe injuries if it touches your bare skin. The drivers must use protective gear, which consists of glasses and suitable gloves. And to ensure that the hose will not accidentally fall during the dispensing process or any other type of accidents, these dispensers have a nozzle that attaches to the receptacle on the vehicle to fill the tank. Compared to the normal fuel pumps which we are used to fill our vehicles with, which lack a locking mechanism. The drivers must use air hoses at the LNG fueling island to blow debris from the LNG fuel nozzle and tank receptacle to prevent contaminants from entering the LNG fuel tank. Filling an LNG tank is as quick and easy as filling a diesel tank. Trucks powered by LNG fuel comparably to diesel at a rate of 12 or more diesel gallons equivalent per minute. The driver may spend approximately 7 minutes at the station from entry to exit. The actual refueling takes around 4 minutes. The LNG dispensed into the truck must be kept at 130 degrees Celsius. For this, the fuel tank is made up of a double-walled vessel with insulation, and obviously the tank stores the LNG on board the vehicle until it's needed by the engine. There are some requirements that need to be met in order to store LNG. Just like the storage tanks in the LNG fueling station, the tankers to transport LNG must be designed to keep the LNG at minus 162 degrees Celsius. These tankers are completely insulated to avoid heat transfer with its surroundings during the transport process. Tankers transporting LNG are very similar to regular 18-wheelers that deliver gasoline or diesel, except LNG tankers are larger in size. Another difference between regular gasoline or diesel tankers and LNG tankers is that LNG tankers have double-walled vessels with insulation to maintain the LNG at its proper temperature in comparison to the others which have a single-walled storage tank. Transporting LNG by roads in a tanker truck must be done very quick since it only relies on the tank's insulation to keep the LNG from evaporating. It must be done way faster than transporting by ships because ships rely on refrigeration and coolants. This gives a truck driver roughly 40 days to deliver the LNG to its destination before it evaporates. The main difference between storing LNG and storing CNG or compressed natural gas is the amount of space that they take up. Compressed natural gas reduces its volume roughly 200 times, while the LNG reduces its volume roughly 600 times. This means that the fuel as LNG is at a higher density than CNG, meaning more energy is contained in the same space. It also means that more natural gas can be transported at once in liquefied state, and other than that, LNG is easy and more economical to ship to where it is needed. Okay, and just to quickly summarize the presentation, natural gas can reduce to 600 times its volume size when it is liquefied. This makes it easier and more economical to store and transport larger amounts. In order to store LNG, it must be kept at a temperature of negative 162 degrees Celsius, and special insulated storage tanks must be used to keep it from evaporating. Fueling an LNG-powered truck is similar to fueling regular diesel trucks, however, you must use different precautions and protective gear when dealing with LNG. When fueling an LNG truck, the LNG can't be dispensed at the same temperature and pressure as it is stored. Transporting LNG by truck must be done faster than by ship, since tanker trucks lack a refrigeration system like ships.